Hey guys, happy Tuesday. Today we are doing 8.1's lesson. Unfortunately, the activity was going to be way too difficult for you to do on your own at home. And this is one of the easier ones. We will do a visual demonstration for tomorrow, but for today we're just going to jump into volume of a cylinder. Alright, so remember we started talking about this before we left, that to find the volume of anything, you are going to, you're going to find the base, whatever the shape is on the base, and then you're going to multiply it by the height. So, for example, if you had a rectangular base that had, let's just say 6 units, and then you gave it, sorry, this looks a little bit bad. If you gave it a height, all you would have to do is think about how many layers of that base that you have. So you're essentially doing length times the width to find the area of whatever's on the bottom, and then multiply it by the third dimension, which is the height. So the same is true for any prism being not a pyramid, so it doesn't come to a point. That means it has the same shape on the bottom and the top. So, for example, a cylinder, which we can most easily compare to like a can of soup. When you have a cylinder, you have a circle on the bottom, and so obviously a circle on the top as well. So all you have to do is find the area of the circle, which we know is pi times the radius squared, and then multiply that by however many layers high it is, which would be the height. So notice that this formula says big B. Well, that's the formula for any shape, any 3D shape. The volume of whatever it is would be the area of the base. So in this case, since it's a circle, we would replace the big B with pi r squared. So putting it all together, inserting that b in this spot here would be pi r squared times h. Okay, so let's try our first example. Remember that since this is a cylinder with a circular base that has a radius of 3, we're going to find the area of that base by doing pi times 3 squared. And then to find the volume of the entire thing, we would multiply it by 6. Now, I am going to disagree with our book on this one because we are going to be using 3 and 14/100ths for most of these. We're not going to round to the 10th place. It just makes more sense to round to the hundredths because it's already going to be rounded for us if we're doing 3.14, since that's 2 place values. Alright, so strategically, I would do 3 squared first, since I know that that's 9. And then I would deal with decimals as little as possible, meaning I would not go with the pi yet. I'm just going to undo that to show you that you're still multiplying by pi, but just don't do it yet because it's easier to get it down to 54 before you have to start dealing with the decimal places. Alright, so again, we could use 22/7 if that was something that was easily divisible by 7, but 54 is not. So we're going to do 3 and 14/100ths times 54. And then move the decimal point back twice. And here's exactly what I was saying earlier, because it's already rounded for us to the hundredths place because we did 3 and 14/100ths. We're going to leave it. So just so you know, when you are doing this with the actual pi button, it's giving you something different. So that's why you should not be using a calculator. I mean, you shouldn't be using a calculator anyways, but you will be confused. Your answer will be slightly different if you use the pi button on a calculator. It is technically a little bit more accurate, but I would rather you do it by hand just to have the practice of multiplying by hand. So if you did use the pi button, which is what the book uses, so you'll notice that in the book it's slightly different, you would have gotten a different place value. You would have gotten a different answer, slightly. So We're going to say the volume of the cylinder is 169 and 56 meters cubed. Cubed because we're talking about filling that cylindrical container. Okay, moving on to our second example. This one, they're giving you the volume instead of asking you for the volume. So instead of doing pi times radius squared times height, you're going to be filling in the height. So, I'm sorry, you're going to be filling in the volume. So 314, which we already know is going to be a nice number since that's just the 3.14 with a different place value, times the radius, which if the diameter is 10, that means the radius is 5. So 5 squared, and then the height is what we don't know, so we'll leave it as h. Alright, so again, I would strategically multiply, and then I would personally, on this one, divide by pi first, only because pi, this is going to be 314 divided by 3.14. So we know that that's just a play on place value. So when we do 314 divided by 3 and 1400ths, that's just going to be 100. So we get 100 equals, and that's 100, just to show you what that came from, equals 25h, and now it's much easier to divide by 25 since that's easily divisible. So we get approximately 4, and again, we're saying approximately because remember that we're rounding pi. So approximately 4 inches for our height. Okay. On your own, try these two, pause the video, come back when you've got them done. And again, think about the order that you're going to multiply things in and just be smart about the way that you're multiplying and dividing. Okay, so again, I worked these out ahead of time because there's a lot of math involved, a lot of calculation, I should say, involved. And hopefully you remembered to round to the nearest hundredth instead of tenths place. If you didn't, it's not a big deal, you can change it now. Take a look at the multiplication, see if you are following along with me here. Okay, example 3 is slightly different because this time we have a can of salsa and some of it is missing from the jar. So we see that the height of the jar, and this is actually not the height of the entire jar, as you can see it stops here. So it's actually just the height of the amount of space that we have. It doesn't include the top of the jar. But anyways, there's 4 centimeters of salsa, and there's 10. The space inside is 10 centimeters, so we know that that's a difference of 6 centimeters. So to find how much salsa is missing, we would be using the 6 centimeters. So volume is going to be pi times the radius, which they gave us, squared, times 6. So again, I'm going to do, leave pi, and I'm going to do 25 times 6 first. That's going to give me 150, which I will then multiply by pi. You see that I'm like rearranging these things again and again. It doesn't matter. So when I multiply 314 by, actually I'm just going to do by 15 because again that's just a 0 on the end that I can manipulate. It's just easier multiplication. Okay, so technically I'm going to put that 0 back on, and then because this was 3 and 1400ths, I have to slide it back twice. So I get about 471 centimeters cubed. And that is the amount of salsa missing. I should label that better because this is a word problem. Okay, so I'll just add that to my answer. All right, and then the last and final example before you do two more on your own, nice quick lesson today, is we're going to have to do some converting in this one. So first let's deal with the volume of the water container, the water bottle. We are asked how many gallons of water the water cooler bottle contains. So if it is 1 foot in diameter, we know that the radius is a half, and then it is 1 7/10 feet high. So we'll do the converting after we find out the volume in feet cubed first. Okay, so we're going to do pi times a half squared times 1 7/10. And we know that when we do, well, I'm going to skip that part first. We know that when we do a half times a half, 5/10 times 5/10 is just basically 25, but then it's two place values, so if I write this out, if I were actually multiplying this out, I would have to move it back 1, 2 place values, so 1, 2, it's actually 25 hundredths times 1 7/10. Okay, this one is not super friendly to multiply. The only thing I think you could do is change the place values so that they're all whole numbers, but I don't think that's really going to make it any easier in the end anyways. So just decide which ones you want to multiply by first. I think I'm just going to do 25 hundredths by 1 7/10 first. And again, I always just ignore the decimal places and put them back at the end. Okay, so that's going to give me, that was 1 7/10 and this was 2500, so 3 place values. So that's going to give me 425 thousandths. Okay, and that's just this part, so I still have to multiply that by 3.14, 3 14 hundredths, excuse me. Okay, and so I'm actually going to start fresh over here where I have a little bit more space. 314, just kind of separate my thoughts here, by 425. Okay, almost done. Okay, and then place values, it was 0.425, so that's 3, 1, 2, 3, and then 3.14. I'm saying these the wrong way so that we see how many place values. I have to move it back 5 times. So 1, 2, 3, 4, 5, almost all the way at the beginning. It gives me 1, holy moly, place values, tenths, hundred thousandths, 10 thousandths. So 3,345 10 thousandths. And we don't need that 0 on the very end there. Okay, so we still have to do some converting. So let's take a look at that. If it told us that 1 foot was equal to 7 5/10 gallons, in order to convert, and I actually should label this so I don't forget what it is that I've got, I need to get rid of the feet and I need to change this into gallons. So they told me that there are 7.5 gallons in 1 foot squared, cubed, sorry. So I'm going to multiply that by my 1 3,345 10 thousandths feet squared, so that when I multiply straight across, I'm going to have, well, actually if you cross cancel, you're going to be able to cancel out the units there, and that's kind of the goal. So we need to multiply this crazy decimal, which I'm going to make some more space, by 7.5. And I put the decimals in there, but I'm just going to ignore them until the very end. Okay, almost done. Second place value. Okay, so moving the place value back 1, 2, 3, 4, 5 times again. 1, 2, 3, 4, 5. And by place value I meant decimal. I get, oh wow, if we're rounding this and actually looking at our options, we see that that's about 10. Look at all this stuff afterwards. It's 10.008755, but again, looking at our options, it's definitely not D, not C, not A, closest to B, so it's approximately 10 gallons. And again, I know that that last step was probably kind of confusing. The only reason we had to go through this last thing right here was because we were in feet cubed and they wanted it in gallons, so we converted right here using this measurement that if 1 foot cubed is about 7.5 gallons, we just multiplied 7.5 gallons by what we got as our answer. So that's approximately 10. Okay, we'll have a similar one like this on our own. So it's kind of a lot of work like we just did, but let's see if you can do it on your own now. Here's number 3. Don't forget that they're asking for what's missing from the jar. And then on your own 4, very similar to what we just did, but this is in meters instead of feet, so it's a different conversion. Okay, so pause the video, try those 2, and then come back and check your work. Okay, so this is number 3. I separated them so that we have enough space. Again, rounding to the nearest 100th instead of 10th place. Actually, it really doesn't matter since it's just a 0. But either way, this is what's missing. And then here is number 4. Crazy number 4. That took a lot of work. Okay, so you are going to take the mini assessment, which I did not add. So let me do that really quickly here. You can see how I make my videos real quick. There's a little picture of Declan and our family. Okay, so the mini assessment. Go ahead and try these 3 and then submit your work. All right, thanks guys. Have a good day.